Next example, example 4, we encounter a different form. This is difference form. So here it's when we have infinity minus infinity. And again, this could be infinity minus infinity. This could be in negative infinity plus infinity. Anything like that. Anything like that. So here, actually, let's do our form. Our form would be, as x goes to 0, this will be infinity, minus, now here you might forget about what's going on with this cosecant, since we don't talk a lot about cosecant, but remember that cosecant is just another way of saying 1 over the sine of x. So we know that as x goes to 0, sine of x goes to 0. So that would mean that the cosecant of x goes to 1 over 0, which goes to infinity. So this is of indeterminate form infinity minus infinity. We can now go ahead and combine our two terms. That is the trick when we have a difference. These two terms should be combined into one fraction in order to create a quotient. Once we have a quotient, we can then work with it, like we otherwise normally would with L'Hopital's rule. So here, we're going to go ahead and get a common denominator, because really, let's do this off to the side, I guess. 1 over x minus 1 over sine of x, since that's what cosecant is. Common denominator here is x sine of x, so this term needs a sine of x, and this term needs an x. So here we have the limit of sine of x minus x all over x sine times, x times sine of x. Now, if we reassess our form, we see that we have 0 over 0, and now L'Hopital's rule is allowed. So L'Hopital's rule, this would be the cosine of x minus 1, and in the denominator we've got a product rule. Derivative of the first times the second left alone, plus the first times derivative of the second. And unfortunately, if we plug in 0, we're going to get 0 over 0 again. So we'll have to do another application of L'Hopital's rule. We can't use a method like dominating terms because x is not going to infinity or negative infinity. It's going to a finite number. So we're going to have to use L'Hopital's rule or something that's a bit more sophisticated. But in this class, L'Hopital's rule it is. So we're going to have, let's do, so the top will go to minus sine of x. The bottom will go to cosine of x plus 1 times cosine of x plus x times negative sine of x, which I'll just make that plus and minus. There we go. And here at this stage, if we plug in, we're going to get 0, 0. So the top is 0. This term goes away, but cosine of 0 is 1, so we end up getting 1 plus 0 in the bottom, which is 2. So this whole thing ends up going to 0 over 2, which is not indeterminate. 0 in the bottom and the top is indeterminate. Non-zero in the top and 0 in the bottom is a vertical asymptote, but 0 in the top, non-zero in the bottom, that's just 0. Okay, part B, same idea. We'll assess our form. Natural log of 1 is 0, so 1 over 0, that goes to infinity, and 1 over 0 goes to infinity, so this is infinity minus infinity. We'll take our limit then by first combining these. So our common denominator here would be x minus 1 ln of x. This would be x minus 1 minus the natural log of x. So then reassessing our form, we're going to have 1 minus 1, which is 0, minus natural log of 1 is 0. So 0 over natural log of 1 is 0, so 0. Which is the correct form for L'Hopital's rule, so we can proceed. Keep wanting to write 0 or infinity there. So we'll have 1 minus 1 over x for the derivative of the top. Now the derivative of the bottom is 1 times the natural log of x plus x minus 1 times the derivative of natural log, which is 1 over x. So here I'm going to go ahead and simplify things a little bit before we do anything else. This is 1 minus 1 over x over ln x plus 1 minus 1 over x. Okay. Now at this stage, if we plug in 1, we can see that we get 0 over 0 again. So let's go ahead and use L'Hopital's rule another time. This is 1, oh sorry, it's not. It is 2 over x. Actually, this would be negative, so positive 1 over x squared. And this would be 1 over x plus 1 over x squared. And now, if we plug in x equals 1, we have, let's see, this is going to be 1 over 2. So this is going to be a half.